And we're on the air. Hello, friends. Welcome to Codementor Office Hours. Today we are continuing our very exciting JavaScript framework series today with another great guest. This is your first time watching Office Hours. Basically what we do is we have on different guests that we're huge fans of all different technology focuses, and have them sort of walk us through a specific concept that maybe isn't being talked about as much or is just overwhelming a lot of developers, and we try to get some clarity. And so what we'll be doing is, if you're in the room with me, you can use the group chat to send questions in. If you're watching the live broadcast, you can use the Q&A app, and I'll be getting notifications about that, and we'll hit as many questions as we can at the end. But without further ado, I'd like to introduce Nick van Weerdenburg, who is the founder of Wrangle.io, a full-stack JavaScript consultancy in Toronto, who specializes in AngularJS, Node.js, and MongoDB. Nick's joining us today from Toronto, and he's going to discuss how to work with poor or no APIs, temporary servers, all with totally test-driven approaches. In short, how to build a hack stack for quickly getting your AngularJS project off the ground and not being handcuffed to your backend. So everyone on mute, very quietly welcome Nick, and I'll kick it over to you, and thanks for being here.
All right, thanks, Mark. Can you see my first slide?
Yep, looks good.
All right, thanks. Yeah, so this topic is building an Angular hack stack, or really just it's fundamental to working with Angular in general, where you have a front-end application which is talking to a back-end, and in a lot of cases that back-end isn't going to be ready before you are. So there's a lot of things that impact a high-velocity sort of seamless development process using Angular. So Wrangle.io, we're a lean, agile JavaScript development and consulting firm, and about 80% of our business is Angular. And we often do front-end projects where we're working with a client where they're refactoring and producing a service-oriented architecture on an existing stack, either Python or PHP, Java, .NET, Ruby, whatever, and we're building the front end. And getting those synced up can be incredibly painful. So in working on these different types of projects, we work with Angular. Obviously, HTML5, we do a lot of Ionic work as well, so this also applies to working on mobile projects. Typically we find mobile and Angular projects are very similar in what you need to sort of produce and consume as an API. So we've done Angular projects, we've done about 30 of them, so just a quick background. And on those projects, about 2/3 of those have been with another backend, and of those, I think we've only had one where there was an existing API that was ready to consume. So what is a hack stack? It's a setup that allows you to work with a broken API delivered late, or it also allows you to build quickly without too much investment in a backend. So if you're prototyping, trying out a concept, you can do a lot of work so your app starts to take shape and you've got your initial feedback, and then that will allow you to sort of finalize where you're going and start to build out your data model in the API with some more information. So you can get a lot more feedback from users in the front end. So, working with the backend API, common case, you build the client, someone provides the API. There's questions on what's a good RESTful API. Often clients aren't used to working with RESTful APIs. We will often have someone promise a nice RESTful API, and we get something that is, just a classic remote procedure call API. Who will test the API? And so what's happened in a lot of cases is that the developers are trying to get the API built, and it's running behind schedule, and they're not testing it, so we end up testing it. And to test while building can be very expensive. So one of the strategies is to actually consider building a test suite against the API as the front-end team so you can validate it. When will the API be ready? I presented to a large Toronto-based institution about how one client promised an API in 2 days, and it took 6 weeks, and another was supposed to be done in a week, and it took 8 weeks. And they just started to laugh because their own situation had been over a year waiting for the API. And the reason for that is APIs are much more difficult than expected when you're refactoring a legacy system. And one of the reasons is you now have to start accounting for business rules, and you have to do a lot more rewriting than expected, especially if you're really trying to define a new document-oriented sort of JSON payload. Like you're coming up with an API that's representing the consumer, the mobile app, or the Angular app, And you don't want to expose the underlying old data model. You want to turn it into something that is appropriate for a REST API, and that can be a lot more work than expected. So, to translate, it's working now. That means it's working and hasn't been tested and will probably be redesigned as the project unfolds. We'll have it in a few days. It might be a few weeks or months, and we are working on it. You might actually get done, the front-end work before the API is ready, and that's happened to us in a couple of cases. And so, fundamentally, this is a different way of building apps, and you have to prepare for the worst. A broken API delivered late in the project. And I'll add another caveat to this, is that there was a move to full-stack developers who would be working on the back end, the data model, the front end, and they'd be doing it, but it would be mostly server-side work. With the move to Angular and browser-based applications, the skill set has shifted. If you're working on an Angular application and someone else is working on a REST API, there's often not a lot of value in having a full-stack developer because of the focus being fundamentally different. And often, the tool, you might have a .NET backend, so your .NET developers will work on that. To have them mastering .NET and mastering very sophisticated JavaScript as you would use in a larger JavaScript code base isn't really an ideal model. So there seems to be, in the industry, a shift more towards specialized front-end and back-end development when it comes to APIs. And so, with that, you're not responsible for both, and you can just, you're working on the front, they're working on the back, and you have to juggle and join them at some point. The other reason that's beneficial is that, when working on the front end, you can really work on the vision of what you need. And you can define the REST API based upon the use cases and what's the ideal model, and that definition can be delivered to the back-end team, and you can collaborate on it. But while they're collaborating on it, you can still move forward, and that's the fundamental goal of building that hack stack, to be able to continue to build the front end on your own timeline. So why such poor predictions in terms of what it's going to take to build out an API? Most times, it's the existing API is so low level it doesn't fit the need for a REST API and client access. And the other thing is the API doesn't actually have lots of business rules. So, it may have a fair number of them, but the front end user interface almost always ends up having more business rules than we would ever want or expect in an application. Especially if it's not an API, there wasn't really a big need to put it back into the service layer. The front end was handling it, and now you need to find and define and implement those business rules, and often through finding errors because you didn't know what the match was between what you could type in an input field and what was being stored in the database. The prior database schema doesn't map well to the future REST API JSON document schema. So one of the great things about Angular is that you can pull a JSON document and work with it, pretty quickly, bind it to different parts of the UI. It can be reactive in terms of updates, generating events, and then you can push it back to the server. That can be a very different model, because it's the UI view of the data that's more of a document-oriented view than what you would originally have built out in an SQL schema and maybe have originally presented through a lower-level services in an application. And as I mentioned, I think already a couple of times, your legacy business rules are scattered throughout the prior view layer, resulting in a large effort to implement in new APIs. So actually, before I move forward from that, one of the strategies to deal with this is a lot of companies, when they first decide to move towards Angular, and they're driven to do that because of the need for mobile and to support mobile, a better user experience, to leverage modern browsers. There's a lot of pressure there. They originally want to quickly turn their existing system into an API, but what often makes sense is to do a multi-layered service architecture. And you put in a new server. It could be in your existing stack, .NET, or it could be a Node server, and you implement your API there and build against that with your Angular and mobile applications. And then that talks to your backend service layer. And the benefits of doing that is that you can convert your existing application into lower-level APIs that don't necessarily have to implement all the business rules and don't have to rewrite or sort of convert the prior data model into the new one. You can provide it as a lower-level service, clean it up a bit, and then your next layer, which is serving up to your mobile or your Angular app, is the one that's turning everything into the nice, pretty JSON API. And by having that sort of separation, you can get the backend API done faster and not have as much effort in building out the API because you're building it sort of fresh and consuming the existing sort of one. So the hack stack to the rescue, it's a setup that allows you to work with broken APIs delivered late, work on a quick prototype, and ultimately it's not a library or tool, but it's a set of best practices based upon experience. This has a massive impact on velocity since it streamlines what otherwise would be a very painful workflow. The amount of communication that can go back and forth in trying to get a single API endpoint working can easily knock off 20 or 30 or even more percentage points of productivity from a front-end team. There's some interesting Agile considerations here as well. How deep is a user story? Like if you're really trying to deliver small, complete pieces of user value, then it's ideally very thin, it's complete, it's end-to-end, it's fully delivered, but APIs do confound this. And so our recommendation is to push as deep as you can, and where you sort of are running out of runway and you don't have the API, you build out the mocks, you document the API, you have the agreement with the back-end team, and you have a test case for the API defined. And that means when you do get finally to that integration point, there's not going to be a lot of insanity around that. So documentation becomes very important. And as a general rule in Agile, if you don't have delivered working code, which can stand in for a lot of detailed documentation, you should have a document. So we do highly recommend having a very clear, complete, concise REST API documentation if it's not going to be there at the point of writing the front end. How to handle crossing the API boundary. So you could go with 2 stories. Generally, I still like to stick with 1 story as much as possible. And going deep and having the test case and having the API spec'd means that you can get close enough to that a secondary story or chore for integration won't be as costly. And the reason for this is you end up with a lot of integration debt and QA debt that's going to take a long time to sort out, and you don't have a lot of visibility into it. So you want to mitigate that as much as possible. And so that deep, complete story, testing where you can, validating where you can, simplifying that final endpoint. In some cases, you may want to go with 2 stories. That's sort of a little awkward because you're talking about the same value being driven, delivered to an end user. And so with that, you figured out how you're going to work, how you're going to handle it with your development process. There's 4 kinds of hack stacks that you can work with. You can go with the backend as a server or service. So Firebase, Parse, those kind of solutions. Those can get set up very quickly. You can start building quickly. You may run out of some runway in doing that for getting the right kind of API defined, REST API. There's some limitations there, some query limitations. So the value, it will be really dependent upon the type of application you're trying to build. And also, it's not so hard to build a simple backend server for testing. So that would be a mean stack with a REST API mapper. So if you're using Mongo and Node and Express, you can build out a backend REST API that's really there for development purposes to support your front-end development. There's a lightweight, sort of opinionated thin server that Wrangle works on called Coast that's built for that purpose. You can use an API service such as Apiary or Swagger. Generally, we found that those provide some value, but they don't provide enough functionality, as actual running code, and they don't provide that much value from a documentation perspective that we'll just as happily use a Word document or a Google Doc and document the API, and then work with a TDD or Angular service-driven approach. And as we've worked through different projects, this has become our more common sort of approach because we find that with doing test-driven development and architecting the right kind of Angular services, that becomes a pretty natural location for mocking out and setting up your data so that you can work on your front end. And our typical Angular teams end up having a service-oriented Angular developer who's focused on the APIs and architecting the right back-end services that are asynchronous friendly, and then the front-end developers who are consuming those APIs, building out the Angular controllers and building out the the flows in the application. So I mentioned this on a prior slide, but where code can't be the documentation, documentation must be written. And that was probably one of the most important lessons where you really do need to communicate with the API team over time, and you can't be talking about the same story in the same sprint. It's just not going to match up. Someone's going to go slower, or someone's going to go faster than they should, and it's just probably not going to work out well. So have the conversations with the team, capture the agreement with the team, document the API, and then go ahead and build the front end while they work on the back end. And you can schedule where that's going to come online and when you can do the integration testing. Sometimes if it's a week later, that's actually great. So you can still do the testing close to the actual implementation. In other cases, it may end up being a little bit longer depending upon what's being prioritized by the back-end team. Back-end teams are also often supporting the existing application and existing customers, and so their time can often be quickly lost to other business requirements and support issues that come up. So the front-end team tends to be more dedicated to a new application or to a migration of an existing application because they're no longer on the core team, and it's the core team with the legacy sort of back-end technology, or the not necessarily legacy, but the back-end server technology that needs to deal with all the fires that might pop up in an existing software company. So what's our Hack Stack 101? This is some of the approaches about getting started on a hack stack. Now this part of this talk was done previously by our CTO Yuri Takteev. Today I'm going to be going through it. So document the API. So that was one of the things that we talked about. Documentation for APIs is hugely valuable. Some of the interesting misses on things like return codes and even types. Like we had one API that was returning randomly for IDs. It was a number, it was a string, it was an object. It was all over the map. There's no consistency because of the legacy evolution of the data model and the changes they've made without migrating prior records, and they had to stay that way for certain clients. And it was a significant amount of work to get that straightened out. This allows you to start making assumptions on the front end. You can unearth problems that would later lead to delays and sometimes significant architectural changes. API can be useful, but Google Docs works fine. So the other thing is mocking the API. So you've got to document it, but now you still got to do the work, right? And if you want to do the work, actually having the data there. So TDD is the first thing to try, and if you're doing test-driven development and you're building out some of the test cases, then you can often create mock data that you can use both for tests and for actually running the application. So you're killing two birds with one stone. This is where we find API is too limiting. It doesn't allow us to address enough of the needs of the use case that we're trying to implement. A mock server can work well, but it's expensive. Depending on the domain, I would still say go with a mock server. If we have a lot of data, it's very query specific, and one of the things that often fail to be captured in the UX design process is how applications work over time with larger sets of data. And a mock server can help considerably with that, but you can also build some of that into your tests. And then client-side mocking, which is our preferred solution. And so you have your test-driven development, but you're also doing the client-side mocking at the same time. So your tests are passing, and your application's running, and you're using those mocks as part of the contract for the tests. One thing I'll point out here, and this has been, this question's come up a few times, is how do you keep everything working over time? And that's an interesting question. I think one thing with tests and also with client-side mocking, you should be pretty happy to get rid of this code where it no longer makes sense in the future. So once you do have an API that's live, having your client-side mocks and keeping them up to date is an expensive proposition, and you may just want to simplify, keep your tests, and you just remove that code where it's not adding a lot of value, and make that decision forcefully and enthusiastically, so that you're not really just adding something that's not needed anymore. It's not really serving the process anymore. So here's a scenario. So you're looking at your tasks endpoint. This would give us the REST access to tasks. We've agreed on the return JSON and what it would look like. We've agreed how problems are going to be handled. This is probably one of the things that's most often missed. Like, what happens if something isn't working? What if it's blank? What's supposed to happen in that case? And that can impact how the API implementation goes. And in an existing system, that can be difficult, where they don't actually have a return code or an error code, or that hasn't really been defined. So now we're waiting for the endpoint. So client-side mock. Leave the task service out of it, but have it proxy all the API calls through the proxy that will be on the mocking. Put the mock data in the task mock data service. Put mock logic in the task mock service. Post, puts, etc. can modify data in memory. And refactor common logic into the mock endpoint service. So what you're doing is you're actually structuring your mock data so that it's easy to understand, and when you've built stuff, you can reuse it when you need it. Now you notice on the task service, we're leaving it out of it, but we are putting in a proxy that may be used. So there is the scenario where you do have some of the backend API and actually having a mix of actually pulling live data and mocking data can be very valuable in building out the story and understanding. And then the API service or similar will direct API requests to mock services when appropriate. So here's what your real service would look like. You have a task service, you have your get tasks, it's obviously simplified for purposes of this. Here's the data. So we're creating some simple data quickly. We're keeping it separate using task mock data. And now we can inject this wherever we want and have access to it. This becomes a lot more flexible. So now you can use it for tests if you want. You can use it for mocking. It's not going to be all mixed up together. For generating the data, there's some good tools for doing that. This can be very useful, save you lots of time. The JSONgenerator.com and the UID generator, place kitten. And now some trivial mock logic. So we have another service, and we're going to basically get the data, the task list. So you can see there that we've injected the task mock data. Now we have get tasks, and returning that using the promise as a promise, so that it's going to act the same way and behave the same way as when we actually put in the live task service. So that's a key point. Make sure to return promises. Promises become a key sort of connective part of your architecture, and it makes it a lot easier to substitute in mocks versus tasks and other sort of, and also for chaining. Some likely problems, you might want to test for a slow connection, so a mock with a timeout, test for a dropped connection, test for server-side errors, loss of authentication, and so you can do things like mock latency. So here we're mocking an endpoint, we're waiting a random time, and then we're returning the data. And you control the latency with a constant. You can mock dropped calls. So for one application, we actually also tested this by building our own little Faraday cage out of tinfoil so that we could put the cell phone in there and sort of test weak reception. So I mean, this is dropped calls in terms of like, the connection times out or something, or breaks, but we also tested that through the Wi-Fi. So looking for different ways that different calls can fail. And so we're waiting a random time, and then we have a maybe drop connection with a percentage time that it might do that. One of the things you'll notice here is that we're using lots of small independent services, and we're composing. So one of the best practices we like to use is composition of services. So we have our task mocks, which is in the task mock data and the mock endpoint. And one of the things that we recommend highly is not being afraid to make lots of services, lots of small services, and to compose them to solve your particular problems. One of the things that we're working on is actually building out a client-side framework to help with this kind of an approach. Right now, we have a sort of an ad hoc solution that we use. So one day, the real API arrives, yay, and now we can actually start connecting with it. So what happens? You can test it with Postman, so understand that the API is actually working. So we usually recommend that. Just have a look at it. If it looks like it's going to be a fair bit of work to get it working the way that it's actually supposed to, there's a great framework we like called Supertest from a Node package, and that allows you to write test suites against your API. And so what we've ended up with in a lot of cases is we have our test suite, and then every time we get a new delivery of the API, we just run the test suite against the API. Cut and paste all the failures, send it back to the backend team, they fix it, and then we iterate that way. That's a lot more effective than going through the app and trying to integrate without validating first. So dealing with changes. So one of the things, run the API serve locally. We've had projects that have really gone off the rails temporarily because the back-end team got really excited and made a lot of updates, and then the front end, what we were integrated with, broke. And then we had to spend time figuring out what broke, why it broke, where it broke. And so you want to release your API changes incrementally to the front-end team. And so having everybody working off the same back-end API server is generally not a good idea, unless you're being very careful, to communicate and control the release of new endpoints. Control your schedule, so when these are going to be rolled out. Set up a toggle between client-side mocks and the real API. So this can be especially good if you're showing the application to lots of people, and the real API is being worked on aggressively. So being able to quickly flip it over to the client-side mocks can be very helpful. Working in a hybrid mode, mixing live data from the live API and mocks can be very, very useful. That's particularly with large data sets, because large data sets drive a lot of understanding of applications that are just really hard to do with test data and with UX type sort of mock-ups and even clickable prototypes. Data really drives a lot of interactions. Filtering API data through a mock layer. So you can add stuff and modify it to make it look like what your end application is going to look like, annotate the data. Use a proxy server, so you can sort of pipe through to other servers. So rather than dealing with setting something up for cores early on, you can use a proxy server. So here's an example of a service that would mix real and mock data. And so we have our mock data, the basic task list, and we have our get tasks, and it's going through the task list for each, and then it's going to return based upon that. Proxying the server. So we have the Express framework, and we are just setting up a quick server for all endpoints, and we're just piping the requests to our other server. So I mean, this is what 1, 2, 3, 6, 7, 8 lines of code, and we set up a proxy that's going to pipe all calls to our node server to the endpoint that we're interested in. So if that endpoint doesn't support cores, we can still access it and continue to deliver. We've had other projects where our developers were waiting for 4 or 5 days before the core setup got finally set up properly on the end server, and there was a lot of false starts. So in cases like that, let's just let's keep moving and get this in place, and then not get sort of hung up and waiting for the data. And of course, this one is surely not for use in production. So working in the hybrid mode, you're mixing data from live API and mocks, you're filtering API through a mock layer, you're using a proxy server. So that is the sort of overview of building a hack stack for working with Angular, how to work with missing and absent without leave APIs. So with that, I guess we will flip it over to some questions. So let me stop sharing.
Cool. Thanks so much, Nick. That was great. So yeah, guys, feel free to throw any questions you have into group chat, or if you're in the live stream, the Q&A app. I'll get us started with actually one that was emailed in that I thought was probably representative of what one of the things a lot of people are thinking about is, do you find that there are significantly more immediate scalability limits with some of the hack stack solutions that you mentioned if people don't make that transition to like a proper API?
So scalability limits compared to like the traditional stack?
Right.
Generally not so much. I guess some of the challenges might be, it depends on what you're building. If you're building your API from scratch, I find the separation of concerns between data and a REST API in the front end can be quite helpful. And so people will architect and focus on the back end without being sort of constrained or caught up in what they're doing in the front end. So you have a more elegant focus on what you're returning and how you're querying. Some of the scalability concerns may come up if you're trying to reformat an older data model. So you have an existing data model and you're querying, and it just is harder to repackage it, because you're doing some transformation. That can still be beneficial in the long run, where you've transformed it into more of a document-oriented API that's fitting the needs of the client, and then you can put in caching. So what we'll often see with a backend, say a PHP system that serves up a website, we'll turn that into a REST API. The performance will generally be similar, but there may be some cases where we do have to do some computation to turn it into the newer sort of data model that we're serving up. And then we'll put in Redis to cache data. And then that actually has a huge benefit overall on scalability, because we now have a caching layer that's more intelligent and normalized to data structures.
Cool. All right. Yeah, that makes sense. So Polkit, who is, I guess, watching the live stream, sent a question in. He was curious, where would you place loopback in this for level stack?
I'm not directly familiar with that. So
Loopback. Okay. Yeah, maybe loopback's not as appropriate for this. All right. So let me go to the chat. We got some other questions coming in. So Richard, who's in the room, this is questions from a while back. You mentioned that you have refactored a number of sites with AngularJS. How do you approach that when the business is based on a large application built in Flash? Does Flash have any place on the web anymore?
So we actually have a significant part of our business is dealing with Flash applications, and there is a really strong need to move away from Flash for companies, because it's not working well with mobile. It's amazing the number of different domains that have like 50% of their traffic's mobile, and then it's a dead technology. It doesn't feel right. If someone goes through a website and they start interacting with a Flash application, you just feel like you're on something old. It's starting to feel like you're on DOS or something. And that might be overstating. And you can have beautiful, clean Flash applications, obviously, because it's very powerful. But it's and then you get the updates to the Flash application. So I would say that there's a strong push to get rid of Flash. Angular is a beautiful sort of fit for that, because there's a lot of similarities. It's JavaScript based. It's front-end application-based, and it has similar sort of data binding concepts with the later versions. Overall, I've seen a mix, though. So for people who have Flash applications, the ones that are really, really complex, that have lots of state in the UI, there seems to be a lot of interest in using React. And so we're also seeing people moving from Flash to React and Flash to Angular.
Cool. Yeah, on that note, actually, we've been, because we've been talking to experts from Angular, React, Backbone, all this stuff. How do you see? Is it possible to build similar type of hack stacks using those other JavaScript frameworks like React, or is Angular unique there?
No, I don't think it's really any different between Angular and React. Angular has more standards, I think. It's more of a full framework. So, you can use React with Angular. But generally, I think Angular is nice because of its testing philosophy, its service architecture. It gives you a lot of guidance in how you might want to go about doing that. And so it's I think, a little more easily grasped. If you're doing that in a newer framework, you're inventing more. There's less sort of, guidance there.
Gotcha. Shaitan, who's in the room with us, could you share some tips on API testing? Do you test the format, assert that all the fields are present, values are or right type, etc.? Did you talk about API testing a little bit?
Yeah. So again, with that, it really depends on what we're trying to get out of it. So we're often doing this to really as a service to ourselves to be able to work on the front end. So we will test usually the API at a high level, and then we'll go into all those nooks and crannies based upon the amount of pain we're seeing in those areas. So fundamentally, we see testing as having confidence in the software, and if we have a beautiful API that we do some simple testing on and it seems to be working well, then we'll go with that. Then if we get to a case where we're seeing more issues with return types and there's a lot more complexity in the domain, that we need to sort of figure out. Then we'll put in more tests.
Cool. And a follow-up on that, are you able to, can you share a template to predefine an API? What do you consider when deciding an API?
So generally, as a template, we have it really depends on the team that we're working with. So we have the API endpoint, we have the return types, we have some of the business rules around it, and we have an example JSON sort of payload. Those things are essential. So if you can see what the JSON is, because often an endpoint by itself won't mean a lot, and then having a description of it to explain what it is. But we don't, have like a formal template that we use.
Cool. Yeah, guys, this is great. Feel free to keep throwing questions in. I had another question, sort of knowing a lot of the Codementor audience. We have a lot of sort of like solopreneurs and solo coders, quickly trying out a lot of ideas. So I think the concept of rapid prototyping is really, really valuable to them. So, I mean, are you seeing the hack stack model being utilized more with, say, established companies quickly launching a new product but are waiting for a proper API, or do you see it as an option for someone just trying to get something off the ground, with little resources as well?
Yeah, I would say that it's a low cost. So if you're really trying out different ideas, you can build quickly. You can test things out. It's a typical way of building with Angular is to put in mock data. You can load up JSON files. This takes it to a higher level where you're actually adding more behavior and you're formalizing the back-end architecture a little bit from a mocking perspective. But it's not really a lot of extra code, so it's definitely the way to go for that. Once you have some clarity around what you're building out, then you could go with a back-end service. Using Mongo and Node could be very effective because in a lot of respects, your Mongo, like if I'm building out something new, my Mongo collections will often reflect the JSON fairly closely, so I'm just passing it through. It really depends where I'm at and what kind of project I'm building.
Right. Was Coast developed as a tool specifically for a hack stack setup, or is it intended to be used for production as well?
For both. Our fundamental focus has been first to support the development process because that was sort of the need and the higher level benefit. But then we've also taken the time to, when we develop new concepts and sort of commonly reused ideas, we put it in there as well. So it is a production sort of tool, but it's focused on really a real thin server concept. So if you have pretty straightforward REST APIs and you can configure them quickly and your data model is going to hold up a lot of the modeling for you in Mongo.
Awesome. Got kind of a specific question. I guess someone's trying to relate this to something they're working on. I have an application with a lot of forms. Is it possible to generate the user interface based on your JSON response to automate all the CRUD operations?
I'm sorry, could you repeat that one for me?
Yeah, so someone's working on an application that has a lot of forms, and he's curious if it's possible to generate the user interface based on JSON responses in order to automate the CRUD operations.
Yeah, I mean, generally, I'm very leery of any kind of automation of anything in the front end. Any kind of tools that you design and generate HTML are more pain than they're worth in the long run. So, from a JSON perspective, if you have a domain that is very CRUD-oriented, it's very repeatable, and you don't really have a complex UX model, then you can do that. And we actually have done that on one project. But the thing is that the actual data that you return from an API usually doesn't have enough information to really define the semantics around the UI because it's data. And so you still have to augment that a lot. And so what we ended up doing was looking at what the JSON payload was, then writing another JSON document that described it, so writing the metadata around what's being returned, and then using those two things to generate a form, and then having CSS to sort of style it. But that was for a very specific domain.
Gotcha.
One of the nice things about Angular generally is it's pretty quick to build a front end, so what you lose there, in flexibility, sometimes is most often too much.
Gotcha. What resources do you recommend for people sort of just getting started, either with Angular or with like the hack stack model, to check out to keep learning more?
Um, so for Angular now, there's a lot of great sort of online learning resources. So there's Code School and there's Pluralsight and a lot of really good sort of Angular courses out there. We teach an Angular course that's focused on best practices. So it does a lot on promises and service architecture. So it's a little bit of a different slant. So one of the caveats we usually give people is the Angular you'll learn from books, especially the early books, is really pretty much the complete wrong way to actually build an Angular application. There's been so much learned over the last few years, and a lot of that's still not captured in sort of the introductory level courses. Angular is a big beast to learn, and a lot of the sort of core software engineering principles that are important in any code base still apply, but people often forget that when they're learning a new framework. So when I learned Rails, how long ago was that? 2004, I guess. So it was like 11 years ago. When it came out, I was quite passionate about Ruby at the time, and I learned Rails, and everybody assumed Rails defined the architecture. And people were doing these bloated controllers, and they were doing skinny models, and it was no architecture to speak of. And then over the years, I went back into doing other work, and I revisited the Ruby community 10 years later, the Rails community, and it looked like enterprise Java 10 years ago. They're talking about adapters and proxies and service layers, and because these are sort of key things. You're architecting a large code base, you need to deal with how you organize the code. And there's a lot of that with Angular as well. Early Angular examples and books all had these fat, bloated controllers and almost didn't use services at all, didn't use directives in a very meaningful way. And so there's some books that are really coming out now that cover some of the best practices. So there's definitely a lot of gotchas there. So learning practical, real-world Angular practices as well on top of just these introductory stuff would be a recommendation.
Great. Jorge, who's in the room with us, what is the hack stack model that would be suggested to replace or rewrite a web app based on a LAMP stack?
Right. So for a LAMP stack, if you're going to rewrite, so you never want to throw out code generally, right? Because code's extremely valuable. So if you have a PHP, server, this was probably 3 or 4 of our early clients who were in this situation. They turned their backend into an API. So while they were doing that, we built the front end exactly as discussed. So working with the mocks and the tests. In some early projects, we just built a node server. So we put a mean stack, and it was temporary. So we built out the Mongo schema, and we would build out the Mongo data, and then build out the API endpoints, build our front end, and while the back end work was being done, then we would move over to the back end. So, and then in other cases, and I guess I'm just trying to think in terms of the percentages. But in other cases, we went and ended up putting the node server and leaving it there, but taking only part of the data from Mongo. So we moved the user authentication layer into Mongo and using some of the newer social authentication libraries that are popular for Node and any sort of new functionality, and the user sort of aspect of it, things that were very specific to the front-end app, we put in Mongo, and then all the data and all the transactions, all the analytics were now in the old LAMP stack. And that so had a REST API. We've also done that with a .NET server as well. So the analytics and sort of the core value of the prior system is maintained behind an API in a service-oriented architecture, but a lot of the new sort of front-end support went into the node layer, and then the caching as well. It's like setting up Redis and other sort of parts of the new architecture.
Awesome. Yeah, definitely don't let your old code go to waste. So Richard sent a good question. When doing development for a client, is it worth building your site around a CMS so that you can do a handoff for content generation later on? It seems like that's done quite a bit, but it seems to restrict complex front-end interactions.
Yeah, I don't know if that's a current client of ours or not, but we're working on a project like that right now. We've also migrated our website recently as well. There's a great talk that I like, and it's called Why Your CMS Smells. And it talks about that exact problem, and it shows all these examples of how CMS is ultimately going to corrupt your design and what it sort of the constraints it puts on it. And the hope and goals of a CMS are usually not realized because the people who want the CMS for handoff and updating things in the future, don't realize that it's still going to be fairly restricted and restrained in what they can do. So part of this you see in the explosion of static site generators and things that now allow you to use Markdown and design templates and be a lot more design friendly. And that's what we did with our website. So we have a Markdown-based workflow. So our marketers have to learn a little bit of technology, so they're using Markdown and Git, but everything else is now free to be designed however we want, and we generate the end site. In the other case, we're working, in another case, we're working with WordPress, and we're attaching, the design to WordPress. We decided to focus on design and built everything statically first because we didn't want to get constrained and compromise on the design. And now we're working backwards and sort of CMS enabling the content. That's needed sometimes for the process and the workflow, but I'm not still a big fan of it. And with WordPress, because it's open source and it's well known, that's fine. If you start getting into Drupal or these other CMS systems, they are so very complex. It's a lot easier to find people that know HTML, right? You need to find someone that knows Sitecore, or someone that knows Drupal, or someone that knows those things. You can find, everybody can learn HTML in a couple of days for minor tweaks, and you can sort of partition with well-structured code. It's not that hard to update and manage your site. But I think Markdown can also have a huge impact there. So my personal bias is against CMSs, but I can definitely see the value in some cases. It's still awkward. But I definitely recommend the talk. I think it was called Why Your CMS Smells, and it goes into that exact sort of issue.
Yeah, that's a really popular issue, I imagine. And I mean, ideally, you want to find clients where you can hand over some plain HTML instead of always going through a CMS, I assume, right?
Yeah.
Yeah.
Now that said, for our blog, we're perfectly happy to use like a CMS type tool like WordPress because a blog has such a fixed workflow where you have to do the same things, and those tools that are brought into that solution in terms of tags and all that kind of stuff is very valuable. There's a lot of stuff there, and you're not that restricted because you want your blog posts to all look the same. But when you get into a website and you start getting more into things that really do need to be designed, you start losing a lot of the value pretty quickly.
Gotcha. Claron sent in an interesting question. It's essentially about migrating data from one site to another. He's trying to migrate data from a fitness site to another fitness site, and he's interested in using Angular to do as much as possible in the browser. Do you have any suggestions about, I guess, utilizing Angular when migrating data from two different systems?
I guess from what's being described is you're using Angular as an admin tool, so you can pull data. So one of the great things about Angular, I've described it to people of my era as being like Power Builder for REST APIs. And Power Builder was a tool for rapidly building front ends against databases back, and it really took off. And then the web came and it completely got destroyed by the web because everyone went to three-tier sort of application architectures. But if you now think that databases have been replaced by REST APIs, it's a level of abstraction in front of the data. Now, what Angular does is allow you to connect to a REST API, rapidly pull that data in, and build a tool around it. So if I were to want to migrate where I had to do data cleanup, and it was a very custom process, then Angular would be a pretty good fit for that because I could bring the data up, make the modifications, submit it to the other site. Really depends on the nature of the data, though. I mean, that kind of stuff could also be done more command line driven, where you're writing or with an ETL tool, but you're pulling the data, cleaning the data, and then saving the data. It's like maybe in an intermediate JSON format, and whether you want to use the UI for that will really depend on the workflow.
Gotcha. Yeah, Claren, hopefully that was helpful. Guys, throw in any last questions if you have it. Otherwise, I don't want to take too much more of Nick's time. Nick, where can people keep up with the work you're doing and more in this concept? Are you tweeting or blogging about this stuff?
Yeah. So our company Twitter account is @WrangleIO. Mine's Nicholas V with a 1 instead of an I. And we also have a newsletter on our website, so if you go to Wrangle.io, you can sign up for our newsletter. And we have a blog, so you can sign up for the blog or subscribe to it.
Awesome. Yeah, well, I think it's probably a good point to wrap stuff up. Thank you guys so much for checking this out. And if I didn't mention it at the beginning, this is also going to be live recorded. This is being live recorded to the Codementor YouTube channel. I always recommend going back and reviewing a lot of the technical parts of the presentation. This stuff usually takes a few viewings to get under your skin, so that'll be available. I'll also send an email out to everyone who RSVP'd with links to the recording and links to some other resources we have. And as always, Codementor obviously has lots of amazing Angular experts, so if you guys are working on any projects and need any assistance, we're definitely at your disposal. But if there's nothing else, Nick, thank you so much for your time, and thank you all for checking it out. And please check out, there's more great office hours coming up, so definitely check out Codementor for that. But with that, I'll say good afternoon, good evening, good morning, wherever in the world you are today, and thanks so much.
All right, thanks a lot.